Welcome to our deep dive into the world of deep learning frameworks. Today, we're exploring two of the most popular tools in the field, TensorFlow and PyTorch. Whether you're a beginner or an experienced practitioner, understanding these frameworks is essential for building modern AI applications. Deep learning has revolutionized industries from healthcare to entertainment, and the right framework can make all the difference in your workflow. In this video, we'll break down the core features, strengths, and unique aspects of both TensorFlow and PyTorch, helping you decide which one fits your needs best. Let's start by understanding what deep learning frameworks are and why they matter. Before we compare TensorFlow and PyTorch, let's clarify what a deep learning framework actually is. In simple terms, a framework provides the building blocks for designing, training, and deploying neural networks. These tools handle complex mathematical operations, manage data flow, and optimize computations, so you can focus on building models rather than reinventing the wheel. Frameworks like TensorFlow and PyTorch offer libraries, APIs, and tools that streamline the development process, making deep learning accessible to more people. Now, let's take a closer look at each framework, starting with TensorFlow. TensorFlow, developed by Google, is one of the most widely used deep learning frameworks in the world. Launched in 2015, it quickly gained popularity for its flexibility and scalability. TensorFlow supports a wide range of tasks, from image recognition to natural language processing, and is used by both researchers and industry professionals. Its robust ecosystem includes tools for model building, training, deployment, and even mobile integration. TensorFlow's strong community and extensive documentation make it a go-to choice for many AI projects. Next, let's see what PyTorch brings to the table. PyTorch, created by Facebook's AI research lab, has rapidly become a favorite among researchers and developers. Released in 2016, PyTorch is known for its dynamic computation graph, intuitive interface, and Pythonic design. It's especially popular in academic circles for its ease of experimentation and debugging. PyTorch's flexibility allows users to build complex models with minimal code, making it ideal for prototyping and research. Its growing ecosystem and active community have contributed to its widespread adoption in both academia and industry. Now, let's compare the core features of these two frameworks. One of the main differences between TensorFlow and PyTorch lies in their computational graphs. TensorFlow originally used static computation graphs, meaning you define the entire computation before running it. This approach offers optimization benefits but can make debugging more challenging. PyTorch, on the other hand, uses dynamic computation graphs, which are built on the fly as operations are executed. This makes PyTorch more intuitive and flexible, especially for tasks that require variable input lengths or complex model structures. Understanding these architectural differences is key to choosing the right framework for your project. When it comes to ease of use, PyTorch is often praised for its clean Pythonic syntax. Its code closely resembles standard Python, making it easy to learn and debug. TensorFlow, especially in its early versions, was criticized for its more complex and less intuitive syntax. However, with the introduction of TensorFlow 2, the framework has become much more user-friendly, adopting many features inspired by PyTorch. Both frameworks now offer high-level APIs, but PyTorch still tends to be the preferred choice for rapid prototyping and research due to its simplicity. Strong community and ecosystem can make a huge difference when working with deep learning frameworks. TensorFlow boasts a massive user base, extensive documentation, and a wide range of tutorials and resources. Its ecosystem includes TensorBoard for visualization, TensorFlow Lite for mobile, and TensorFlow serving for deployment. PyTorch, while newer, has quickly built a passionate community, especially among researchers. Its ecosystem is expanding, with tools like TorchServe and PyTorch Lightning making development and deployment easier. Both frameworks benefit from active support and frequent updates. Deploying models to production is a critical step in any AI project. TensorFlow offers a mature suite of deployment tools, including TensorFlow Serving, TensorFlow Lite, and TensorFlow GS, enabling deployment on servers, mobile devices, and web browsers. PyTorch has made significant strides with TorchServe and ONNX support, allowing models to be exported and run in various environments. While TensorFlow's deployment options are more established, PyTorch is catching up quickly, making both frameworks suitable for real-world applications. Choosing the right deployment tool depends on your specific needs and target platforms. Performance and scalability are crucial for training large models or handling massive datasets. TensorFlow is designed for scalability, supporting distributed training across multiple GPUs and even TPUs. Its static graph approach allows for advanced optimizations, making it suitable for large-scale production systems. PyTorch has also improved its scalability, now supporting distributed training and efficient data loading. While TensorFlow may have a slight edge in large-scale deployments, PyTorch's performance is more than adequate for most research and development tasks. Both frameworks continue to evolve, narrowing the performance gap. Visualization is essential for understanding model behavior and debugging issues. TensorFlow offers TensorBoard, a powerful tool for visualizing metrics, graphs, and model performance. It's widely used for tracking experiments and gaining insights into training processes. PyTorch users often rely on third-party tools like TensorBoard X or integrate with TensorBoard itself, thanks to recent compatibility improvement. While TensorFlow's visualization tools are more integrated, PyTorch's flexibility allows users to choose the tools that best fit their workflow. Both frameworks support effective visualization, aiding in model development and analysis. Both TensorFlow and PyTorch are primarily designed for Python, but they also support other languages. TensorFlow offers APIs for JavaScript, C++, Java, and Swift, making it versatile for different development environments. PyTorch, while mainly focused on Python, has C++ support through its libtorch library. This allows for integration into high-performance applications and systems. If you need to work in multiple programming languages or deploy models in diverse environments, TensorFlow's broader language support might be advantageous. However, for most users, Python remains the language of choice. TensorFlow has seen widespread adoption in industry, powering applications at Google, Airbnb, Uber, and many other tech giants. Its stability, scalability, and deployment tools make it a favorite for production systems. PyTorch, while initially more popular in academia, is now gaining traction in industry as well. Companies like Facebook, Tesla, and Microsoft use PyTorch for research and production. The choice between frameworks often depends on company culture, existing infrastructure, and specific project requirements. Both frameworks are well supported and trusted by leading organizations worldwide. Academic and research settings, PyTorch has become the framework of choice for many. Its dynamic computation graph and intuitive interface make it ideal for experimenting with new ideas and quickly iterating on models. Many cutting-edge research papers and projects are now implemented in PyTorch, reflecting its popularity in the scientific community. TensorFlow is still used in research, especially for projects that require scalability and deployment, but PyTorch's flexibility and ease of use have made it the preferred tool for innovation and discovery. Learning curve is an important factor, especially for newcomers to deep learning. PyTorch's straightforward, Pythonic syntax makes it easier for beginners to pick up and start building models. Its dynamic nature allows for immediate feedback and easier debugging. TensorFlow, particularly in its earlier versions, was considered more challenging to learn due to its static graph approach and verbose syntax. However, TensorFlow 2 has addressed many of these issues, making the framework more accessible. Today, both frameworks offer extensive tutorials and resources to help users get started. Both TensorFlow and PyTorch offer high-level APIs for building models. TensorFlow's Keras API provides a simple modular way to construct neural networks, making it easy to prototype and experiment. PyTorch's NN module and Torch, NN APIs offer similar functionality, allowing users to define custom layers and architectures with minimal code. These high-level APIs abstract away much of the complexity, enabling rapid development and iteration. Whether you prefer Keras or PyTorch's approach, both frameworks make model building accessible and efficient. Flexibility in defining custom layers and operations is essential for advanced research and development. PyTorch excels in this area, allowing users to create custom modules and operations with ease. Its dynamic computation graph makes it simple to experiment with new architectures and techniques. TensorFlow also supports custom layers through Keras and low-level APIs, but the process can be more involved, especially for complex operations. Both frameworks are powerful, but PyTorch's flexibility gives it an edge for rapid experimentation and innovation. Debugging is a critical part of the model development process. PyTorch's dynamic computation graph allows for immediate feedback and easier debugging using standard Python tools. You can use print statements, breakpoints, and debuggers just like in regular Python code. TensorFlow, especially in its early versions, made debugging more challenging due to its static graph approach. However, TensorFlow 2 has improved debugging capabilities, supporting eager execution and better error messages. Both frameworks now offer tools to help identify and fix issues efficiently. Integration with other tools and libraries is important for building complete AI solutions. TensorFlow integrates seamlessly with Google Cloud, TensorBoard, and TensorFlow Extended TFX for end-to-end machine learning pipelines. PyTorch works well with tools like NumPy, SciPy, and scikit-learn, and is increasingly supported by cloud platforms such as AWS and Azure. Both frameworks support ONNX, enabling model interoperability and deployment across different environments. The choice may depend on your preferred ecosystem and existing infrastructure. Deploying models on mobile and edge devices is increasingly important for real-time applications. TensorFlow Lite is a dedicated solution for running models on smartphones, IoT devices, and embedded systems. It offers tools for model optimization and quantization, ensuring efficient performance on limited hardware. PyTorch Mobile provides similar capabilities, allowing models to run on Android and iOS devices. While TensorFlow Lite is more mature and widely used, PyTorch Mobile is rapidly improving, making both frameworks viable options for mobile AI. Cloud platforms play a significant role in scaling AI solutions. TensorFlow is tightly integrated with Google Cloud, offering managed services for training and deployment. PyTorch is supported by major cloud providers like AWS, Azure, and Google Cloud, with dedicated tools for distributed training and deployment. Both frameworks benefit from cloud-based GPUs and TPUs, enabling faster training and experimentation. Your choice of framework may depend on your preferred cloud provider and the specific services you need for your project. Access to pre-trained models and libraries can accelerate development and experimentation. TensorFlow Hub offers a wide range of pre-trained models for tasks like image classification, text analysis, and more. PyTorch's TorchVision and TorchX libraries provide similar resources, making it easy to leverage state-of-the-art models. Both frameworks support transfer learning, allowing you to fine-tune existing models for your specific needs. The availability of pre-trained models helps reduce training time and improves performance on many tasks. Good documentation and tutorials are essential for learning and troubleshooting. TensorFlow offers comprehensive documentation, official guides, and a vast collection of community tutorials. PyTorch is also well documented with clear guides and active forums. Both frameworks have strong online communities, making it easy to find answers to common questions. Whether you're a beginner or an expert, you'll find plenty of resources to help you master either framework and solve any challenges you encounter along the way. Exporting models and ensuring interoperability between frameworks is increasingly important. TensorFlow models can be saved in various formats, including saved model and HDF5, and deployed across different platforms. PyTorch supports model export through TorchScript and ONNX, enabling compatibility with other frameworks and deployment environments. ONNX, the Open Neural Network Exchange format, bridges the gap between TensorFlow, PyTorch, and other tools, making it easier to move models between ecosystems. This flexibility is valuable for teams working with diverse technologies. Hardware acceleration is key for training deep learning models efficiently. TensorFlow supports GPUs and TPUs out of the box, enabling faster computation and larger models. PyTorch also supports GPU acceleration via CUDA and is increasingly compatible with specialized hardware. Both frameworks automatically detect available hardware and optimize computations accordingly. If you require TPU support, TensorFlow is the more mature option, but PyTorch is quickly catching up. Efficient hardware utilization ensures faster training and better performance. Many groundbreaking research papers are now implemented in PyTorch, reflecting its popularity in the academic community. Its flexibility and ease of use make it ideal for experimenting with novel architectures and techniques. TensorFlow is also used in research, particularly for projects that require scalability and deployment. Both frameworks are supported by leading conferences and journals, and many open-source implementations are available for both. The choice often comes down to personal preference and the specific requirements of the research project. Let's look at some real-world case studies. Google uses TensorFlow for products like Google Photos and Translate, leveraging its scalability and deployment tools. Facebook relies on PyTorch for research and production, powering features like automatic image tagging and content moderation. Other companies, such as Tesla and Microsoft, use both frameworks for different projects depending on their needs. These examples highlight the versatility and power of both TensorFlow and PyTorch in solving complex, real-world problems. Both TensorFlow and PyTorch are open-source projects with active contributions from developers worldwide. TensorFlow's GitHub repository is one of the most popular in the AI community, with thousands of contributors and regular updates. PyTorch's open-source model encourages collaboration and rapid innovation, with many researchers and engineers contributing new features and bug fixes. The open-source nature of both frameworks ensures transparency, reliability, and continuous improvement, benefiting the entire AI community. Licensing is an important consideration for commercial projects. TensorFlow is released under the Apache 2 license, which is permissive and suitable for both open-source and proprietary applications. PyTorch uses the BSD license, which is also permissive and widely accepted in industry. Both licenses allow for commercial use, modification, and distribution, giving organizations the flexibility to build and deploy AI solutions without legal concern. Always review the latest license terms to ensure compliance with your project requirements. Security and privacy are critical in AI applications, especially when handling sensitive data. TensorFlow and PyTorch both offer tools and best practices for securing models and data. TensorFlow provides features like model encryption and secure deployment options, while PyTorch supports secure data handling and privacy-preserving techniques. Both frameworks are actively maintained to address security vulnerabilities and ensure compliance with industry standards. Implementing robust security measures is essential for protecting your AI solutions and user data. Visualizing results is crucial for interpreting model performance and communicating findings. TensorBoard offers interactive dashboards for tracking metrics, visualizing graphs, and comparing experiments. PyTorch users can leverage similar tools or integrate with third-party visualization libraries. Effective visualization helps identify trends, diagnose issues, and present results to stakeholders. Both frameworks support a range of visualization options, making it easier to understand and improve your models. Understanding how models make decisions is increasingly important. Both TensorFlow and PyTorch support tools and libraries for model interpretability, such as LIME and SHAP. These tools help explain model predictions, identify biases, and build trust in AI systems. TensorFlow's integration with TensorBoard and other interpretability libraries makes it easy to analyze model behavior. PyTorch's flexibility allows for custom interpretability solutions. Ensuring model transparency is essential for ethical and responsible AI development. Reinforcement learning is a growing area in AI, and both frameworks offer support for building RL models. TensorFlow provides libraries like TF Agents and TensorFlow Reinforcement Learning for developing and training RL agents. PyTorch supports RL through libraries such as Stable Baselines and PyTorch RL. Both frameworks are used in cutting-edge RL research and applications, from robotics to game AI. The choice of framework may depend on your preferred libraries and the specific requirements of your RL project. Natural language processing, NLP, is a major application area for deep learning. TensorFlow offers libraries like TensorFlow Text and TensorFlow Hub for NLP tasks, including text classification, translation, and sentiment analysis. PyTorch is widely used in NLP research, with libraries such as TorchText and Hugging Face transformers. Both frameworks support state-of-the-art models like BERT and GPT, enabling powerful language understanding and generation. The choice may depend on your preferred libraries and the specific NLP tasks you're tackling. Computer vision is another key area for deep learning. TensorFlow provides libraries like TensorFlow Image and TensorFlow Hub, supporting tasks such as image classification, object detection, and segmentation. PyTorch's Torch Vision library is widely used for computer vision research and applications, offering pre-trained models and datasets. Both frameworks support advanced architectures like RaiseNet, YOLO, and Mask RCNet. The choice of framework often depends on your preferred tools and the specific requirements of your computer vision project. Time series analysis and forecasting are important in fields like finance, healthcare, and logistics. TensorFlow offers libraries and tools for building and training time series models, including LSTM and GRU architectures. PyTorch also supports time series modeling, with libraries like PyTorch forecasting and custom implementations. Both frameworks enable the development of accurate forecasting models, helping organizations make data-driven decisions. The choice may depend on your preferred libraries and the complexity of your time series tasks. Audio and speech processing are growing fields in AI. TensorFlow provides libraries like TensorFlow Audio and supports models for speech recognition, synthesis, and classification. PyTorch is widely used for audio research, with libraries such as Torsioio and SpeechBrain. Both frameworks support state-of-the-art models for tasks like voice recognition and audio analysis. The choice of framework may depend on your preferred libraries and the specific requirements of your audio project. Generative models like GANs and VAEs are at the forefront of AI research. TensorFlow and PyTorch both support the development of generative models, with extensive libraries and tutorials available. PyTorch is particularly popular for GAN research due to its flexibility and ease of experimentation. TensorFlow offers tools for building and training generative models, with strong support for deployment. Both frameworks enable the creation of innovative AI applications, from image synthesis to data augmentation. Transfer learning allows you to leverage pre-trained models for new tasks, saving time and resources. Both TensorFlow and PyTorch support transfer learning, making it easy to fine-tune existing models on your own data. TensorFlow Hub and PyTorch's Torch Vision provide a wide range of pre-trained models for various applications. Transfer learning is widely used in computer vision, NLP, and other fields, enabling rapid development and improved performance. Both frameworks make transfer learning accessible and efficient. Hyperparameter tuning is essential for optimizing model performance. TensorFlow offers tools like Keras Tuner and integration with Google Vizier for automated hyperparameter search. PyTorch supports hyperparameter tuning through libraries such as Optuna and RayTune. Both frameworks enable efficient experimentation and optimization, helping you find the best model configurations. Automated tuning tools save time and improve results, making them valuable additions to your deep learning toolkit. Efficient data loading and preprocessing are crucial for training deep learning models. TensorFlow's TF Data API provides powerful tools for loading, transforming, and batching data. PyTorch's data loader and dataset classes offer similar functionality, making it easy to work with large datasets. Both frameworks support data augmentation, shuffling, and parallel loading, ensuring efficient training pipelines. The choice may depend on your preferred data formats and preprocessing workflow. Batching and parallelism are important for speeding up model training. TensorFlow and PyTorch both support mini-batch training, allowing you to process multiple samples simultaneously. TensorFlow's TF Data API and PyTorch's data loader enable parallel data loading and preprocessing, maximizing hardware utilization. Both frameworks support multi-GPU training, making it possible to scale up experiments and reduce training time. Efficient batching and parallelism are key to building high-performance AI systems. Tracking experiments is essential for reproducibility and progress. TensorFlow integrates with TensorBoard for logging metrics, visualizing results, and comparing experiments. PyTorch users can leverage tools like MLflow, weights and biases, and TensorBoard for experiment tracking. Both frameworks support logging hyperparameters, metrics, and artifacts, making it easy to manage and analyze experiments. Effective experiment tracking helps you understand what works and accelerates model development. Version control and reproducibility are vital for collaborative AI projects. Both TensorFlow and PyTorch support saving and loading models, ensuring consistent results across runs. Tools like DVC and MLflow can be integrated for data and model versioning. Ensuring reproducibility helps teams collaborate effectively and maintain high-quality code. Both frameworks encourage best practices for version control, making it easier to manage complex projects and share results with others. Community support and events play a big role in the growth of deep learning frameworks. TensorFlow and PyTorch both host conferences, workshops, and meetups, fostering collaboration and knowledge sharing. Online forums, GitHub repositories, and social media groups provide platforms for asking questions and sharing solutions. Active communities ensure that users have access to the latest developments, best practices, and troubleshooting tips. Engaging with the community can accelerate your learning and help you stay up to date. Summary: both TensorFlow and PyTorch are powerful deep learning frameworks, each with its own strengths and unique features. TensorFlow excels in scalability, deployment, and industry adoption, while PyTorch is favored for its flexibility, ease of use, and popularity in research. The best choice depends on your specific needs, project requirements, and personal preferences. Whether you're building cutting-edge research models or deploying AI at scale, both frameworks offer the tools and support you need to succeed. Thanks for joining us on this comprehensive comparison.